Bypassing the pip. I'm connected to positive side here, and the spark should be coming out of here. Well, I will be explaining here what I was doing here with this Ford. So I'm gonna start checking here. So this vehicle, they took it to the shop because they checked for fuel pressure, and it didn't have fuel pressure. So they started replacing fuel pump, I think, and fuel filter. And after doing that, still no fuel pressure. So they took it to the shop. But myself, I don't like to start with fuel pressure. Whenever a vehicle doesn't have fuel pressure, I like to start with the ignition system, because if the computer doesn't receive, well, first the computer applies power to the fuel pump for about 2 seconds with key on, engine off, and then it is waiting or expecting for crankshaft position sensor RPM. If the computer doesn't detect the RPM, it doesn't power up the pump, the fuel pump. Okay, so the first thing I did is check for a spark out of here. Coming out of the coil, no spark. So then I checked for power here and here. The test light connected to ground, and both sides I had power. So at that moment, that means power is coming in and going out. Okay, so at least the coil is not open. That's what it pretty much. So I said, okay, so I do not have control. So then at this point, what I did is check on this side. This is the ground side control coming from the module. And it goes to instrumental cluster. So the ignition control module is providing the ground to the coil here, and at the same time this one is used for the instrumental cluster for RPM signals on the tachometer. Okay, it didn't have control, nothing coming out of here, the ground wasn't applied. So okay, my next test was to apply on the pip on this wire. You can see the pip is coming out of the distributor, is flowing that way, power, and goes to the computer, and also it goes to the ignition control module. Okay, so the PIP is a PIP, pickup ignition profile. So this one is picking up the signal from the Hall effect sensor inside the distributor. It's producing every time that one passes through a magnet. There produces a voltage, high voltage, like 12 volts or some high voltage. It goes from 0 every time it passes there. That's this. So it goes away from the magnet, little gap, next contact, and start doing something like this, digital square waveform. Okay, so it's producing high voltage, and that voltage is sent out to two places: the powertrain control module, the computer, the PCM, ECM, and the computer process that signal, and that signal is used for the computer mainly for a lot of stuff, but mainly it's used for fuel pump control. We can hear when I was doing the test light there, touching there, we can hear the fuel pump coming on, and then also is sending that signal here to the ignition control module on the pin 1. So when the ignition control module receive a high voltage, no, it produces the spark. Produces a spark when key on engine cranking. As soon as the engine is already running, the computer is not using that. The module is not using that anymore. That signal, but the computer is still using it. And then now, oh, before I move to a different subject, I was with my test light. I was connected to a positive side in my test light, and then I was touching here. Every time I touch here, we can see I was simulating the signal that what the Hall effect sensor inside the distributor is doing. I was touching here, and because I was connected to a positive side here, I'm producing this, and we could see the spark and everything works. Okay, we move to a different place here. Okay, so my next, then I wanted to explain how these work. The spot connector. So now the computer is taking place to take for the ignition timing to advance or retard dependence of the condition through this one, the spot. So we already work on the first pin. So there are 4 pins on the ignition distributor. Yeah, 4. PIP, signal coming in to control, to trigger basically this the ignition control module. The spot. This signal is used when the engine is running. The computer is controlling the spark here, advancing or retarding the timing based on the engine condition parameters. That's why when we're checking for timing, when the engine is running, we have to unplug this connector here. So that way we are checking for base timing only. The computer is out of the picture. Okay. Let's move to a different wire. Okay. As any module, when we see the word module, basically it's like a little computer, and like any computer need power and ground mainly. So the ground is provided here by the distributor, basically here. Okay, so we needed to check good ground on this one. At this point I didn't have to because I got a spark. So what do I have? I have good ground, I have good power, and I have everything I needed. So basically I didn't have only the PIP signal. So I didn't need to check any powers and ground or anything on the module at that point. Okay, and this is the power. We can see here this power is coming here, hot in on start and run. So this power is coming when we turn on the key or engine cranking. Okay, the next one is going to be Coil control, we addressed that one already, and this is the start. In reality, I don't know exactly what this one means. What is that for? Can rely on that one, but I don't know what is the module doing with that one. Here's a little bit explanation how the Hall effect sensor inside the distributor works. The PIP is profile ignition pickup. So as we can see here, inside the distributor they have these little like vanes. It's gonna have, well, I don't know exactly how many this one will have, but I will assume it will be one per cylinder. So 8, I'm gonna say in this case. Okay. As I was explaining, every time this passes through the magnet here is creating, the high voltage, which is basically this. And they're showing here, this is a low RPM, and we can see here the repetition. And then higher RPM, we can see here the frequency, the repetition is more frequently. So basically, like any Hall effect sensor, they need power, ground, and signal. So we can see here the signal, the ground is sent by the computer, power is coming from some source there, and then the signal. And here's a little bit of explanation how this system works. The profile ignition pickup sensor is a Hall effect type switch located in the distributor. It sends the power control module PCM information on engine speed and crankshaft position. The Hall effect device operates by manipulating of magnetic field. Basically, you can read if you want that one, but this is the explanation how the system works. Oh, this is something I'm reading here, description and operation of the system, for people who wanted to understand how it works. But basically, I understand how it works and how to do the testing, but you need to know that before doing any testing to expect what are you gonna be expecting to. Okay, so we can see here the purpose of the Hall effect sensor is a cam sensor and crank sensor pretty much. And yeah, there are 8 blades. They pass it through. Each one represent one cylinder. Yeah, you see, each of them represent the position of the crankshaft through the Hall effect from 0 to 12 volts. So one of them gotta be different to identify the cylinder number 1. From 0 to 12 volts in a square wave pattern. Okay. And this is information on how the ignition control module works, description and operation. You can read it here. I was having a question myself on that start wire there, so here's the answer.